Hello, thanks for joining us for today's webinar. Welcome to Scala 211 with Jason Zaugg. I'm Laura Masterson, Community Manager here at Typesafe, and I'll be your host for today's presentation. The Scala team at Typesafe has been busy over the last year working to make the platform faster, smaller, and more stable. In this webinar, Jason will take you on a tour of these changes, give you tips for upgrading, discuss the plans for upcoming releases, and field your questions. So without further ado, here's Jason.
We really wanted to focus on these other sort of non-feature aspects of the language in 2.11. Refine what we already have rather than adding new things. So you won't see a lot of code in this presentation that teaches you how to use new features of Scala. The things that you've already learned for Scala 2.10 should be sufficient. So what I'm going to go through for the next couple of slides is kind of drill down a little bit and give you a highlight of some of the pieces of work that have happened that contribute to these themes. By the way, down the bottom you can find a link to these slides. There'll be quite a few links in the slides themselves if you're interested in seeing more details. So I encourage you to take a look at those afterwards. So within the standard library, we've been lucky enough to encourage Rex Kerr to help us out in the collections part of the library in particular. And he's been focusing on performance in a few areas. So just a couple of highlights here is we've optimized the implementation of map and flat map and a few other heavily used methods on list. And I think he benchmarked some 5x speedups in some cases there. He's identified and plugged a memory leak in stream. So once the stream has materialized, we can kind of release the memory held onto by the thunks that were responsible for creating that stream. That can reduce the retained set of memory, which can help performance quite a bit. He's also contributed 2 new map implementations which can avoid the tax that one has to pay for generic collections by specializing on the key type. So a map whose keys must be reference types rather than a generic type, which in Scala could also encompass primitives or reference types. In this anyref map, we've used that within the compiler itself in some performance critical places and seen some good speedups because of that. And that's part of the standard library. So you can, if profiling suggests that you're spending a lot of time in map lookups, you can look into that for your own application. There's also a variant long map where the keys are of type long. One of the big areas where people ask us to invest is in making the compiler itself faster. We've sort of got a two-pronged approach to that. The first approach which we've been taking is to, rather than making the compiler itself faster, is to compile fewer files. So Grzegorz Kozakowski has been leading that effort over the last 18 months or so to improve the incremental compiler. The incremental compiler is shipped as part of SBT. However, it's also offered as a standalone library, and that library is available in other build tools, Maven and Gradle, and it's also available by default by in the build function from Scala IDE and IntelliJ. So the idea of incremental compilation is to keep metadata around from the previous compile run, which helps us to identify the dependency graph between the files within your project, and exploit that dependency graph after you've edited some files and you want to recompile your project. So the coarseness of this dependency graph in the past has meant that certain changes in many common patterns of code, for example, a typical play application, have led to this recompile the world problem. So just simply adding a method in one file that's not used anywhere else, except in that file, but by virtue of the fact that it's not private, has caused large recompilation problems. So the idea here is to retain more fine-grained information about the previous compilation run, and in particular, we identify now we index the identifiers within each file. What we can do then is exploit this information to more aggressively prune the compilation batches. So if you add a method to a file called foo_bar, we can know in some cases that because another file did not contain the string, essentially foo_bar, that it need not be recompiled. This work actually is not strictly part of Scala 2.11. We've made this as part of SPT, and therefore it can work with Scala 2.10 and 2.11. However, there's some corner cases which are likely to be fixed only in Scala 2.11. So that was the first prong of improving the kind of performance, the amount of time that you spend waiting for the compiler. The second prong is making the compiler itself faster. Here, there's been some interesting work happening in the back end of the compiler. So Miguel Garcia from the EPFL Scala team has generated a new backend for Scala, which is streamlined in that rather than representing your code in this intermediate representation called iCode through the compilation pipeline, it instead skips that step and goes directly from the Scala trees to JVM bytecode. This streamlining saves a little bit of time during compilation, and furthermore is designed this in a way that there's some opportunities for parallelism within the backend. I've got a link there with more details of that he's documented for this new backend of the compiler. In Scala 2.11, we've merged in the bytecode emitter, which is a portion of his work. And our plan is in Scala 2.11.1 and .2 to merge the remaining work, which is the portion of this backend which is enabled when you use the compiler flag -optimize. A complementary piece of work is called delambdify. This piece of work is also only available in 2.11 behind a -y flag. Both delambdify and bcode are planned to be the defaults in Scala 2.12. So in Scala 2.11, we're going to be shipping those for early adopters. Delambdify actually copies, in many ways, the ideas of Java compilation of lambdas. And the upshot is that we can produce smaller bytecode, and bytecode which is more amenable for a feature that we'll be working on in the next 12 months, which is invoke dynamic-based lambda translation. I'm going to talk a bit more about that later on in the presentation. It's also worth noting that this work in the back end has a twofold potential for performance improvements. The streamlined nature of the bcode backend means that the compiler itself has less work to do and can run more quickly. And the new optimizer, which fixes certain bugs that have plagued us in the old one to do with inlining, mean that it can actually emit faster code. So the final prong of compilation, improving the speed of batch compilation, is some old-fashioned profiling and tuning of the compiler itself. Now, this is a difficult task, largely because the compiler's been around for a while and there's been plenty of people who are interested in making it faster. So the big wins seem elusive. It's not that this is a piece of code which has not been optimized before, so one can't simply go in and expect to find 25–30% inefficiencies which can be erased in a simple manner. But this hasn't stopped us from trying to make some gains, because there are definitely gains on offer. And as I was working on this stream of work last year, I was sort of inspired a little bit by this famous speech of Al Pacino in Any Given Sunday. And even though individual patches that we're applying might only have 0.5% to 1% improvement along the way, if we add up enough of those, we can get meaningful improvements in the compilation speed. So in Scala 2.11.0, we've started this process. So I've got links here to pull requests which contain multiple patches in each of these that are fighting for these inches of performance. My measurements in benchmarking the compilation speed of a small sample project, the Scala decompiler, showed 10 to 20% improvement, more so in warm compilation where we're reusing a symbol table. We've got more patches on the way. It just takes a little bit of time for us to get these reviewed and make sure that we're not compromising correctness in the name of performance. But it's definitely an area where we see potential, and we'll continue to work on this through the 2.11 maintenance release stream. So the second theme of 2.11 is to make things smaller. What we want to do here is, within the library, is to reduce Scala library.jar to a more kind of focused core library.jar, and we've done that by spinning out modules. So as of Scala 2.11, support for XML is shipped in a separate jar. The parser combinator library is shipped in a separate jar. The portion of the library to do with that supports the continuations plugin is yet again a separate jar. This sort of mirrors what was done before with the Scala swing jar. These modules are now just plain old SBT projects. They're in dedicated Git repos, and what we're hoping is that this lowers the barriers to community contributions. We've already attracted a maintainer now for Scala Swing in its new home, and that has been unmaintained in the previous release cycle. So we're kind of excited about this potential. It also lowers the barriers to new modules, and we've got two of those which are sort of incubating through the 2.11 process, and I just want to touch on those because they're kind of interesting. This module is Scala Pickling, which is a serialization and deserialization library, and its kind of unique feature is the fact that it generates efficient picklers based on macros which at compile time which do reflection essentially at compile time over the types which you're trying to serialize and deserialize. And that can move into compile time things which other serialization libraries had to do at runtime. This is still incubating, but it's got a few early adopters who are really big fans of it already, so we're excited about the future of this module. This is a shameless plug for a module which Philip Haller and I co-authored, Scala Async. This is essentially a DSL that helps you compose programs which are using scala.concurrent.future. It's also implemented with macros. Syntactically, it looks remarkably similar to the built-in language support that C# offers for await and async. And got a link up here in the title of the slide to the project. You can start using this one today. This one is the status is it's hatched. We've frozen the API to this module, so you can rely on this not being backwards compatible in the future. We've applied this this theme of making things smaller to the collections library. So collections over the years have accumulated a large number of classes, and even the big redesign of collections in Scala 2.8 sort of took the position that it would bring everything forward. I mean, the names of backwards compatibility. However, there are parts of the collections library which are problematic, and we've often debated, what do we do with these? Do we remove them, even though we don't maybe have a alternative for people to use, or do we just leave them as they are, encouraging implicitly people to start using them and more people to depend on them. We've taken the stance now in Scala 2.11 that we don't want more people to depend on things that we know are problematic. And along these lines, we've now deprecated the variety of proxy classes, synchronized versions of collections traits, forwarder classes, immutable adapters, and this framework for scripting actions over collections. If you feel, by the way, that we've been too aggressive with some of these, we'd love to hear some feedback. Generally, the feedback we've got so far has been relatively positive, that we've targeted the right things to remove, but we want to hear all opinions on this. So these classes are deprecated. They'll still be available in Scala 2.11, but by default, our plan would be then to remove them from Scala 2.12. In a similar vein, we've identified places in the collections library which should have been essentially originally shipped with tighter modifiers. By modifiers, I mean things should have been final or sealed. And by having these extension points, or these hypothetical extension points left throughout the collections hierarchy, we essentially have our hands tied in some places where we can't make performance fixes, or in some cases even correctness fixes, because the number of permutations you have to consider when people could override every single method or extend from every single class, even if it was originally written as an implementation detail rather than as an API, means that you enter a sort of a stasis, and you just can't move things forward. Once again, though, we wanted to be sure that we weren't breaking things. We weren't going to break people's code unnecessarily. So what we've done is actually analyzed the way that real projects are using collections. So we looked at all of the Scala projects that were published in Maven Central, which depended on Scala Library 2.10, and using some bytecode analysis, we've determined that, you know, in the wild, at least for the open source community, these methods that we have now marked as final, rather, we've deprecated overriding these methods or deprecated inheriting from certain classes, were not in the wild actually used as extension points. Another area that we've trimmed of the collections is the intersection of parallel collections and views, and this was an area which we deemed to be a design mistake of the past, and the tax that was levied on the collections hierarchy by having to support this case was so great that we were unable to execute certain important bug fixes while we were kind of living with this hierarchy. So again, we went out and found that these methods were not being used, at least in the open source world, and took a decision to simplify the hierarchy. We've also put the compiler itself on something of a diet to try to make it a little smaller. Within our own code base, we now enforce modularity for the interpreter, aka the REPL, the presentation compiler, which supports the Scala IDE and Eclipse, and for Scaladoc. These are still shipped in the same Scala compiler.jar. We'd actually like to change that in the future, but this is not such a big deal for most people, and this was the path of least resistance to make sure that we didn't unnecessarily break certain tools like Maven integration with Scala. We've removed the experimental support to target the CLR. This was sort of incomplete code which had been floating around, and we took the decision, again, not to encourage people to start projects which were depending on something which was experimental. Through the work in Scala 2.10, we'd applied renovations to the implementation of the pattern matcher and to the bytecode emitter. And in Scala 2.11, we've removed the old implementations of those. In Scala 2.10, they were shipped behind a flag, so people could fall back to them in case they encountered some unforeseen bug in the new implementation. And furthermore, we found reams of dead code which have accumulated over the years, and Van actually did some analysis over our code base to find which pieces of code weren't used within the compiler itself, and slim that down fairly drastically. Another area that we've invested in fairly heavily within this release cycle has been kind of our infrastructure around building, around releasing, around reviewing of pull requests. So a problem that we had in the past was every month or so, when we wanted to ship a milestone, we would we'd find suddenly that we'd broken an API which was we've broken an API within the compiler which was relied upon by SPT, or relied upon by the refactoring library within Scala IDE. So what we do now is we actually build this entire chain from the compiler, the modules, the IDE, and SPT upon every commit, and we just don't merge changes which break these inadvertently. We've done a lot of work to clean up our build. We still have an ant build. We're a bit retro in that respect, but after the cleanup, we're well positioned in Scala 2.12 to actually switch to like a standard SPT build for the compiler and standard library itself. SPT is already the standard for the new Scala modules. We've simplified making building the Scala distribution itself. There's a bit of work to do here, but we've taken what was a multi-day process down to a multi-hour process. We've still got hopes to actually do this automatically on a nightly basis in the next 6 months. And generally around the release process, that there are a number of things which we've automated around creating release notes and all these sorts of things. And the idea is to free us up to release more often, but without taking time away from doing what we should be doing, which is actually working on the compiler, working on the library itself. So building the IDE and SPT, Incremental Compiler, on every commit is a good start, but and of course we build our test suite. We execute our test suite, which has got a few thousand regression tests touching the compiler and touching the library. But what we really still found is that on major releases or release candidates, we'd be chasing regressions that were reported by the open source ecosystem. So the idea here is pretty simple. What if we had a community build that could actually every night rebuild the open source ecosystem against the latest and greatest compiler and library? So it doesn't sound such a difficult task until you look into the details. Fortunately, we've had a few fairly tenacious people working on that from our side. So Tony Kanai and Josh Sureth have worked on some internal tooling at Typesafe, something called dbuild. And dbuild can essentially check out all of these projects from Git, inspect their SPT builds to understand the graph of interdependencies between them, rewire these builds such that these builds are not only building against the latest Scala compiler, but also building against the just built versions of each other, and executing the tests, doing this all on a nightly basis, and furthermore configuring this tool such that we have an ecosystem of specs of Scala Test, of Akka, Play, Slick, Shapeless, Spray, and about half a dozen other projects which are built now on a daily basis, and that encompasses close to 1 million lines of code. We finally got all this into place about 2 or 3 months ago, and it immediately paid dividends. We were finding regressions, before we were releasing our code, and we think that this is going to be a bit of a game changer with respect to our productivity as we continue our development through the next year. So we'll be looking to expand the scope of this and add more projects into the mix. And so, of course, in the interest of making things stabler, we've been closing lots of tickets. There's 600 odd tickets which have been closed in Scala 2.11. In general, our process is to target fixes back for the maintenance release of 2.10 where it makes sense. And a definition of makes sense is it's low risk and high reward. And so in addition to these 613 tickets fixed in 2.11, there's also a couple hundred which are fixed in 2.10.3, 2.10.4, and so on, which are also available in the 2.11 builds because they've been merged onto that branch. Just a couple highlights of fixes. SI 261, it's not often that we can claim a fix in a 3-digit ticket number, but we've found finally an important inconsistency between the way that privacy is specified and implemented, and brought those two things into line. We've had this long-standing bug with Java interop, where type members in Scala classes and a few other patterns of Scala code could generate generic signatures which would be deemed invalid, and so Java code couldn't link against them. We've finally lifted the limit that case classes need not have fewer than 23 parameters. This is kind of a interesting thing for projects like Slick, for example, which use case classes to model database tables. We have not extended the range of tuple n and function n above 22. So what this fix does is once you go above 22 elements in your case class, you don't have the unapply method of the companion, which would return option of tuple 2. However, pattern matching is still working on this. We've found a number of cases where soundness checks, so this is where the compiler is checking that according to the rules of variance, for example, you're only using type parameters of a class in places where they're allowed to be used. We found a few holes in these checks, and these have been plugged in a number of places. This might be an interesting thing if you're upgrading and the compiler is now telling you about some of these things. You might need to ask for assistance about what you need to do to either fix this correctly or disable the check. There's ways, which are relatively straightforward to go down either path there. A new major feature in Scala 2.10, experimental feature, was compile time metaprogramming, aka macros, and a reflection API, as well as runtime reflection. The main difference in the API within Scala 2.11 is that we've added quasi-quotes, which is a high-level API for constructing and also for pattern matching on trees. So this is of some interest to macro authors. Runtime reflection.
Oops.
Sorry, I'm back. Runtime reflection was only safe for single-threaded programs in Scala 2.10. This has been corrected in Scala 2.11. The API, which is available with compile time and runtime reflection, has been expanded in response to the requests of a number of people who've been using this to write macros and basically found gaps where things were more difficult than they needed to be. I've got a link here to the full changelog and a migration guide. And because this is an experimental module, we don't guarantee full source compatibility from one release to the next. But every effort has been made, as you'll see in the migration guide, to sorry, I just had another call coming and I had to decline. Every effort has been made to offer a way to, with minimal changes to your source, make your program run in Scala 2.11. The status is still the same in Scala 2.11. I might, if people have questions about the experimentality of macros and reflection, it might be a good topic for discussion in the Q&A afterwards. So, Scala 10.11 will be released imminently. We've just gone final, and I'll be tagging and pushing the release later tonight. So stay tuned for the release notes coming up on scalalang.org and a blog post on the Typesafe blog. When you upgrade, I've got a couple tips that might help you. So before you actually go about upgrading, you're best to run your 2.10 compiler against your project and take care of any deprecation warnings that you've been leaving hanging, because these often signal things which you need to change to be able to upgrade. You might also consider upgrading to the latest releases of open source libraries that you depend on, for example, Specs or Scala Test. When you actually upgrade, you can, as I said, read through the detailed release notes that we'll post to scalalang.org. You'll have to go through your 2.11 build and make sure that the dependencies that you're using are published for Scala 2.11. And a great way to check their availability is by searching on Sonatype. So I've got an example link in the slides here that show you how to see once Scala Test is published for 2.11, what version has been published. If you're using parts of the standard library which have now been modularized, you'll also have to update your build to depend on those explicitly. So if you're using the XML library, either just by using XML literals in your code or by using parts of the library, if you're using Scala Swing or Scala Parser combinators, you will have to touch your build. Put a link here with a sample that shows you how to do that. And you can also, if you're an author of an open source project and you want to cross build with Scala 2.10 and 2.11, this sample also shows you how to go about this. If you're an author of macros, you should follow the migration guide that I mentioned before on the API changes to macros. And once things are compiling, you might also want to take note of new deprecations which are issued under 2.11. If you run into any problems, please post a question on our mailing list, Scala user, or alternatively over on Stack Overflow under the Scala tag. So, how can you get involved? If you want to try out Scala right now, you can do that in your browser with Typesafe Activator. Keep an eye on the Activator site. In the coming days, we'll have a template which shows you how to get started with Scala 2.11 itself. Right now, I've just linked to the Scala 2.10 template. You can download a distro from scalalang.org. As I said, Scala 2.11 will be added to there probably over the weekend, or certainly by Monday or Tuesday next week. If you want to hear more from us on Twitter, I've included the accounts for the Scala team and for Typesafe. We've got a few mailing lists and links also to local user groups, which are a great way to find other people who are using Scala, interested in Scala, and share your experiences. There are a couple courses which I recommend, so functional programming in Scala or reactive programming. These are free courses on Coursera. Scala is open source and we rely heavily on contributions from the community. We're always proud of the long list of contributors that we have. And we've got a guide here that helps helps you if you're interested in becoming a contributor to Scala. This can be contributing to code, documentation, to testing, translations. There's many ways that you can help out. And you can also be a part of the 5th annual Scala Days, which is hosted this year in Berlin. I'm really looking forward to that one. And on that note, I'll finish the slides and we can start getting into a couple of the questions.
Yes, thank you so much, Jason. Really appreciate you presenting today. It sounds like over half of the people on the webinar today are planning to upgrade within the next 3 months. So I hope everyone found the session helpful and informative. So let's hop into the Q&A. Jason, I didn't know if you wanted to kind of kick things off with discussing the macros and why they're still listed as experimental. I did see a question come through the Q&A pod touching upon that. So can you please maybe elaborate a little bit?
Okay, sure. So one question we have is, will macros become non-experimental? Will we introduce new flavors of macros in Scala 2.12 or 2.11? For 2.11, the answer is no. There are new flavors of macros being researched, for example, annotation macros. Before we kind of commit to that, we have to sort of step back and look at the experience with macros in general. So def macros have been actually quite popular, the take-up. Certain domains really have profited from these. So there are DSLs, Scala Async, SPT13 can both be thought of DSLs, which are backed by macros. There are libraries which are interested in high performance code, so tools like Scala Breeze or Spire, Scala Blitz. Serialization libraries, like I showed you, Scala Pickler, also Play is using macros to reduce boilerplate required for people who want to convert their objects to and from JSON. So we're really happy about all these use cases and how they were served by macros. However, the authors of macros still have a pretty tough time. You end up needing a fairly deep understanding of compiler internals to make macros that are truly robust. That is, that they work for all inputs, not just for the happy cases. The APIs that we have to offer to macro authors are enormous, really, and they're tightly coupled to compiler internals. So usually for non-experimental features, we have to offer compatibility guarantees so that your code written today will still work in a year's time. And it's difficult to do this for huge APIs. And that's a real active problem that we're actively looking into to see, is there a way that we could expose sort of a smaller API for macros. And finally, macro flavors that compute return types or add members, such as macro annotations or white box macros, are something of a blind spot for IDEs that don't want to execute or can't execute the macro. So the experience of users callers to the macro in, say, IntelliJ or Eclipse under modes where macro expansion is disabled is sort of suboptimal. So I work pretty closely with Eugene at DPFL, and he's leading a project which is seeking to address these problems. And that's called Project Palladium. So I believe he's going to be presenting some preliminary work from this at Scala Days. So we're quite looking forward to seeing what he's got coming there.
Great. I hope that answered everybody's questions. Thanks, Jason. Next question here is asking if you could touch upon the status of lazy vals and locking.
So there's some work happening there. For those unfamiliar with the problems at play, lazy vals in Scala sort of encapsulate the double-check locking pattern. However, if the initializer of the lazy val, so the right-hand side of the lazy val, calls into code which itself takes locks, you have the classic problem with locks, that you can get into deadlocks. And this is exacerbated by the fact that there's one lock, that lazy vals lock on this. So if you have multiple lazy vals in an object, their initializers are all locked on this. So in cases where you don't really have what looks like a cycle, there are still possibilities for deadlock. The EPFL team are prototyping some alternative implementations for lazy vals. They're doing this in the experimental compiler that Martin's working on at the moment called Dotty, which is kind of a better venue for that sort of research. It's a little bit easier for them to play with these new ideas. But the idea is to see how this experiment pans out, and then if it's fruitful, backported onto the mainline of Scala. It's not something that we've included on our roadmap for 2.12 yet, but if this research goes along quickly, it's something that we'll consider.
Great. Kind of continuing on with the roadmap in Scala 2.12, there's been a couple questions about.
I think I missed a slide actually on that, so.
Oh, okay.
Go ahead with the questions, but I might need to. I feel like I missed a slide.
Sure. So a couple, just to kind of bring a couple of the questions together. Will 2.12 require Java 8, and are there any other kind of big future plans for future releases that we can discuss on this webinar?
Mm-hmm. Is my screen still shared?
Yes, it is.
Okay. So this is the slide that I must have skipped over. So our themes for the next 12 months, I say the next 12 months rather than 2.12 because we will try where possible to deliver some of these features on the maintenance releases of 2.11. But the themes for the next 12 months are Java 8. So if you've had a question of do we require Java 8, that's one I'll need to answer separately. But the themes themselves are Java 8, which means we want to at least have an option to emit lambdas in the same way that Java compiler does now for Java 8, and that's something I've been prototyping over the last couple of days, and you can see my branch from the link here. We want to investigate using default methods and interfaces as a way to improve the fragility of traits. So when you add methods with bodies to traits, and finally, sort of for feature parity with Java 8, something we've added experimentally in 2.11 is that Scala functions can now implement an expected type, which is a single abstract method. In the same way that a Java lambda implements a functional interface, an interface with one abstract method. So this is interop and sort of parity with Java 8 is one of our big themes. Will we require Java 8? That's a difficult question. So it really depends on two things. What's the adoption of Java 8 going to be like at the time when we're releasing Scala 2.12? And secondly, how compelling are the benefits that we can deliver by mandating Java 8? So we're going to go ahead and start working on the benefit side of things, and we have to really wait and see a little bit about the adoption. It's not something that we can control. On the other hand, we are sort of actively monitoring that. So Typesafe actually launched a big survey recently about people's intentions for Java 8 upgrades. I think you can find that on the Typesafe blog.
Yeah, it's on the blog, and also I think you can just access the report on the homepage of the website.
Okay.
Yeah. Great. So moving on to the next. Oh, go ahead.
No, go ahead.
Was there more things on Java 8 that you wanted to touch upon?
No, that's all.
Okay. Moving on to the next question. Someone asked about what about Scala and .NET? Jason, is there anything you can touch upon with regards to the .NET space?
Yep. So as I said, one of the things that we did was actually we took the decision to remove the .NET backend. So right now, if you need to run Scala code on .NET, your path would be through IKVM. So you compile to Java bytecode and run that on .NET through IKVM. We've actually had some interesting reports of people doing that with some success. So one, I believe a customer of ours was doing that to run Scala to write custom functions in Excel, which requires .NET. But we don't have any plans to resurrect the native support for a compiler backend targeting .NET. Our kind of feeling is that the more interesting backend for us, if we want to be a multi-backend language, which is quite a laudable goal, is JavaScript. So there's efforts at EPFL at the moment to produce JavaScript backend. In fact, people are already are using the early prototypes of that, which is looking quite promising.
Great. Cool. So next question. What are the plans for language specification? I think maybe it'd be helpful to go over some of Adrian's efforts to move the spec to Markdown. Yeah.
Yep. So the history of our spec is that it was a LaTeX document. It was not exactly what you'd call a living document. So after about Scala 2.9, it didn't see a lot of attention, didn't see a lot of love. Our kind of de facto position was that the full language specification was the spec as of 2.9, and language features, which went through our SIP process, the Scala improvement process. The SIP document essentially gives a delta from the base specification. But it was a little bit of a weak answer on our part. So we've decided that it's really important for us to have a live spec, one that is easy to fix mistakes, it's easy to contribute to. So with the help of the community, so Ian McGuinness has done the painstaking work, which was kind of committed and completed recently by Adrian from the Typesafe team. We've actually ported the spec to Markdown, and that's now committed in the main repository. So this gives us really the ability to say that language changes to the compiler must be accompanied in the same commit with a change to the spec. And this level of discipline is an important kind of check and balance, because if we can't spec a change that we've made, then perhaps it's too complicated or it needs to be rethought. And one user of the spec that we work with is IntelliJ. And so IntelliJ uses the spec to implement a presentation compiler within their plugin for IDEA. And we know that the spec covers parts of the language, but it's not sufficient. So it would be ideal to cover more of the language, such that instead of having to ask us questions about some of the finer details of type inference or implicit search, they could consult the document. That's a big amount of work, though, and we don't believe we can get there, in the next sort of 12 months. But we do plan to keep the document now a living document, and for the things that are already within the scope of specification, really strive towards some parity between implementation and specification.
All right, great. Well, I think we should wrap up. There's been so many great questions, but a lot of them I think would be really helpful to respond to people individually and make sure you're in touch with the right person. And people have had questions about plans for reactive programming classes and upcoming books for bringing Scala to the masses, which are all really great. So we'll be following up with everybody directly. I'd like to again thank Jason and also Greg, who's been handling the Q&A and hopefully helping everybody out with their questions throughout Jason's session. As I mentioned at the beginning, this webinar and the Q&A as well has been recorded, so we're going to be posting it on our YouTube channel in a day or so, and also sending a direct link to everybody who registered for the webinar. If you have any questions, please feel free to reach out to me directly. My email is laura.masterson@typesafe.com. And if you have suggestions for future webinars, we'd be happy to hear them. And I know Jason already did his Scala Days plug, but we really do encourage the community to register and attend this year. It should be a fantastic event in Berlin. There are discounts available for user group members, students, companies sending a large group of people. So there's lots of ways for you to be involved. And yeah, again, feel free to reach out to me if you have questions for that. And with that, I think we're going to say goodbye. Look for the recording online soon, and hope you enjoyed the session.